Today's lesson is graphing quadratic functions. Remember, a quadratic function has the form of y equals x squared plus bx plus c, or standard form. So when we are graphing this, we need 5 steps that we're going to use. Step 1 is to find the axis of symmetry. You can use the formula x equals negative b divided by 2a. The second step is to find the vertex. Use your axis to substitute in the equation for x to find your y. So your vertex is going to be an ordered pair. Your third step is to find the y-intercept. That is always going to be whatever c is in your equation. Your fourth step is to find one point that's not on the axis of symmetry and then mirror it. And then your fifth step is just to draw your parabola. So let's look at an example. Graph the function x squared plus 4x plus 5. This is my a, this is my b, 5 is my c. So to find the axis, I use the formula x equals negative b over 2a. I plug my numbers in. I have a negative 4 divided by 2 times 1. So x equals a negative 2. That's my axis. To find my vertex, I already found that it's at negative 2 on the x-coordinate. To find my y, I plug negative 2 in for x. Negative 2 squared is 4. 4 plus a negative 8 is negative 4. Negative 4 plus 5 is positive 1. So the vertex is at negative 2, 1. The y-intercept, we said, is always your c. So the y-intercept, x is 0, y is going to be 5. And then a point not on the axis. So the point that's not on the axis, I look at the axis is at negative 2. I pick a point to the right, or you can pick one to the left. I'll choose a negative 1. At negative 1 squared is 1. 1 plus a negative 4 is negative 3. Negative 3 plus 5 is a positive 2. And now if I want to mirror that point, the other side of the axis would be at negative 3. The y-coordinate would still be at 2. Now I have all my points, and now I can graph. So if I draw my axis of symmetry, it's at x equals negative 2. Plot my points. My vertex is at negative 2, positive 1. Y-intercept is 0 and 5. Point not on the axis, negative 1 and positive 2. My mirror point is negative 3, positive 2. And I'll mirror one more. I'll mirror my y-intercept. And 2 steps to the right of the axis. I go 2 steps to the left of the axis. And now I can draw my parabola. You can do example 1c yourself. Example 2, the only difference with this one is that it's ax squared. Everything else stays the same. So let's do this one. Here's your a, here's our b, here's our c. I find my axis, x equals negative b over 2a. That gives me negative 18 over 2 times 3. So my axis, negative 18 divided by 6 is negative 3. That leaves my vertex at negative 3. And I need to find where it crosses the y-axis, or the y, or finds the y coordinate. So I put a negative 3 in for x. Negative 3 squared is 9. 9 times 3 is 27. Plus 18 times negative 3 is a negative 54. Plus 13. So now, if I simplify that, that gives me a negative 27 plus 13 gives me an answer of a negative 14. So I have negative 3 and negative 14 as my vertex. The y-intercept, that leaves you tells you when x is 0, what is your y? So I put in 0 in, or you look at c in the equation, which is 13. So the y-intercept is at 0 and 13. A point not on the axis. Point not on the axis, I would choose a number on one side of the axis, so a negative 3. So I'll choose a number to the right of negative 3. I'll choose a negative 1. When x is a negative 1, what is your y? Negative 1 squared is 1. 1 times 3 is 3. 3 plus a negative 18 is a negative 15. A negative 15 plus 13 is a negative 2. And then we need to mirror it. So if I went 2 steps to the right of negative 3, 2 steps to the left of negative 3 would be negative 5. It would still be at negative 2. Now we can graph our points. So my axis of symmetry is at negative 3. And let's plot our points. We have negative 3 and negative 14. I'm going to count by 3s for my y-axis. So this is 3, 6, 9, 12, 15, negative 3, negative 6, negative 9, negative 12, negative 15. So our points, we have our vertex, negative 3 and negative 14. So negative 3, negative 14 would be roughly here. We have y-intercept 0 and positive 13. So 0, 13 would be about here. Negative 1 and negative 2. So negative 1, negative 2 would be here. Mirror that. Negative 5 and negative 2 is here. Then I'm going to mirror my y-intercept on 1, 2, 3 steps from the axis of symmetry. I go 3 to the left. 1, 2, 3. There's my axis, or my mirrored point. Now I can draw my parabola. There's my graph. You may do 2b yourself for extra practice. The third example, the quadratic is in the form of y equals ax squared plus c. You'll notice that the b is missing. So I can still find these 5 points. So I used find the axis of symmetry. So x equals negative b over 2a. This is my a. I don't have a b, but I have a c. So that gives us a 0 for b. 2 times 5. 0 times 10 is just 0. So the axis of symmetry is 0. That means their vertex, when x is 0, y is 4. Our vertex is the y-intercept. So I have the same point there. Now I need to choose a point not on the axis. The axis is at 0. Let's choose a 1. When x is 1, y would be 1 squared is 1 times 5 is 5 plus 4 is 9. If I mirror that, negative 1, you're at a positive 9. Now I can come over here and graph my points. The axis is at 0, so y-intercept. Plot my points. The vertex is at 0 and 4, and I'm going to count by 2s on the y-axis. So 2, 4, so this is 0, 4. That's also my y-intercept. A point not on the axis, I go 1 and 9. So 9 would be here. Mirror that one. Negative 1 and 9 is here. Now I can draw my parabola. You can do 3B yourself for extra practice. 4A, finding the zeros of a quadratic function. Here I'm giving you choices. You can either use a graphing calculator or factor the trinomial and then plot points using the equation. To find the zeros, I would factor, so y equals, what do I multiply to get positive 9, but add them together to give me a negative 6. That would be a negative 3 and a negative 3. Now if I'm finding the zeros, I'm really finding the y, or the x-intercepts. So the x-intercepts, y is 0. So I have x minus 3, and since they're both the same, I only need to do this once. So the 0, I would add 3 to both sides. So x equals 3. So when y is 0, x is going to be 3. That is going to be my zeros. We are not going to graph this because we already know where these zeros are. You can do this next one yourself for extra practice. Same as for C. Now example 5, an application. Baseball is thrown straight up with an initial velocity of 50 feet per second. The ball leaves the player's hand when it is 4 feet above the ground. At what time does the ball reach its maximum height? Hint, you need to use the formula h equals negative 16t squared plus vt plus s. The v standing for the velocity and s standing for the starting height. So I need to plug in the numbers for the velocity and the starting heights. So I have h equals negative 16 t squared plus 50t plus 4. And we want to find out at what time does it reach its maximum height. So the ball goes up in the air and then it comes back down. This is our parabola. We want to find out this point, the highest point. What time does it take for it to get up to that point? And we know that the axis of symmetry goes right through that. So that would be our formula, x equals negative b over 2a. But in this case, we don't have an x, we have a t instead of an x. So we would use the formula t equals negative b divided by 2a. And again, this is my a, this is my b, this is my c. So the height, or the time, I would take a negative 50 divided by 2 times negative 16. When you solve it, you have 50 over 32. And you use your calculator to divide it out. That gives you about 1.56 seconds for it to reach its highest point. If you need practice with another problem like that application, you can do 5B. Otherwise, your assignment for next time is lesson 96. You only have 5 problems, 3, 6, 8, and 9, and 30.